Have you ever just looked up at the sky and wondered, what are the rules? Not just for us, but for everything? Well, today we're not going to treat physics like some stuffy subject from school. Nope. We're going to treat it like the greatest detective story ever told. So let's get into it. The investigation starts right now.
And this is the central mystery, isn't it? It just sounds kind of crazy. How could one single thread connect an apple falling from a tree, the ocean tides, and the way entire galaxies spin around, billions of light years away? Well, believe it or not, that's exactly the case our cosmic detective is trying to crack.
Our whole investigation really starts with a very human thing, wonder. For as long as we've been around, we've looked up at the stars or seen a rainbow and asked that one simple, powerful question: why? Why does it work like that?
And to answer that why, we had to invent a special kind of detective. This detective isn't looking for a person, but for a principle, for the laws underneath it all. And we call that detective physics. Its whole job is to unravel the secrets of nature itself.
So what even is physics? Well, the name itself comes from the Greek word for nature, and that's really the whole game. Finding the most basic, fundamental rules that explain, well, everything. It's almost like we're trying to find the source code for reality.
Now, our detective doesn't just make wild guesses. It has a very specific toolkit, one that's been tested over centuries, the scientific method. It's all about observing the crime scene, the universe, then running controlled experiments, building a mathematical model of what's going on, and, this is the key, using that model to predict what's going to happen next. That's how we separate fact from fiction.
Okay, and this is where it gets really cool. The ultimate goal here isn't just to solve a bunch of separate little mysteries. The big dream, the holy grail, is to find one single, elegant explanation that connects all the clues into one beautiful story. This is what we call the quest for unification.
And this right here is maybe the first huge break in the case. Isaac Newton comes along and has this incredible insight. He realizes that the force pulling an apple down from a tree is the exact same force that's keeping the moon locked in orbit around the Earth. One single law explained things on Earth and in the heavens. This was absolutely revolutionary.
And it turns out, this whole unification thing is a pattern. The next big aha moment came from James Clerk Maxwell. He was looking at two things that seemed totally separate: electricity and magnetism. But he discovered they were really just two sides of the same coin. He unified them into electromagnetism. And, as a bonus, his work revealed that light itself is just a wave of this stuff.
So, the natural question is, how far can we take this? As physicists dug deeper, they found that all the different forces we see every day, like friction or tension in a rope, or the force from our muscles, they aren't fundamental at all. They're just the surface-level effects of a very, very short list of prime suspects.
And that list has just 4 names on it. That's it, just 4. Think about that for a second. All the incredible complexity of the entire cosmos, from a star exploding to your phone working, it all boils down to just 4 fundamental forces. The detective has narrowed the field dramatically.
So, who are these 4 suspects? Well, first you've got the strong nuclear force, the undisputed boss that glues the centers of atoms together. Then there's electromagnetism, the force that governs electricity, magnets, chemistry, and light. Then the weak nuclear force, which is a bit more obscure but is crucial for things like radioactivity. And last, and seriously least, is gravity. Just look at those numbers. Gravity is unbelievably, ridiculously weak compared to the others.
So, that raises a question, right? If gravity is so incredibly weak, why is it the one that runs the show on the cosmic scale? Why does it shape galaxies? Well, it's because gravity is always attractive. It only pulls. Electromagnetism, on the other hand, can push or pull. And since most big things like planets and stars have a pretty balanced number of positive and negative charges, their net electromagnetic force kind of cancels itself out. Gravity, however weak, just keeps adding and up and up. And if you want to feel for just how strong electromagnetism is, think about this. When you hold a book, the gravitational pull of the entire planet Earth is trying to yank it out of your hand. But the book doesn't just phase through your fingers. Why? Because the electromagnetic repulsion between the atoms in your hand and the atoms in the book is more than strong enough to fight the entire planet and win. It's not even a fair fight. So besides figuring out the 4 forces, the how things interact, our detective also found something else: a set of absolute, non-negotiable, unbreakable statutes that the universe has to follow no matter what. These are the conservation laws.
The key idea here is that if you have an isolated system, like a closed box where nothing gets in or out, these specific quantities, the total amount of them, will always stay the same. Energy, momentum, charge, they're not just suggestions, they are the fundamental legal code of the cosmos.
Let's just take energy. You can't make new energy out of thin air, and you can't destroy it. All you can do is change its form. A stone you're holding up high has potential energy. As it falls, that potential energy turns into the energy of motion, kinetic energy. And when it smacks into the ground, that kinetic energy transforms again into a bit of heat and sound. But if you were to add it all up, the total amount of energy is exactly what you started with.
Then, of course, Albert Einstein came along and threw a huge twist into our detective story. His famous little equation, E equals mc squared, it revealed something mind-blowing. It showed that mass itself is just an incredibly concentrated form of energy. This was a unification of its own, combining the conservation of mass and the conservation of energy into one, deeper, more fundamental law.
But here's the most important thing to remember about this whole cosmic detective story. It is not over. Not even close. The case file is still wide open, and the investigation is more active right now than it has ever been.
Remember that quest for unification? Well, we've made more progress. Physicists actually managed to show that at high enough energies, the electromagnetic force and the weak nuclear force are really the same thing, the electroweak force. The dream now is to rope the strong force into that theory, and then the final boss, bringing gravity into the fold. That is the ultimate puzzle.
And that really brings us to this incredible thought from Einstein. Maybe the biggest mystery of all isn't what the rules are. Maybe the biggest mystery is that the universe has rules we can understand in the first place. The fact that this chaotic cosmos is actually logical, and that our brains can somehow decipher that logic, well, that's maybe the most wonderful clue of all.
So, the case continues. We found the prime suspects, the four forces. We found the unbreakable laws they have to follow. But there are still so many unanswered questions, so many dark corners of the universe we have yet to explore. With things like dark matter and dark energy still completely mysterious, who knows? The biggest clues might be just around the corner. What will we discover next?